the principal component analysis. As I said earlier, data comes in all the shapes, like maybe higher dimensions. If I'm talking about, obviously it creates some kind of the complexity in the implementation. So we need to handle the convention in such a way that we have to reduce those particular dimensions. Friends, one important point we observed there, like even to delete or even to handle the missing values, it is always important to discuss with the subject matter experts, and it is always important to discuss with the domain experts. Then only you have to take the decision. Simply, we cannot remove the data items, okay, whatever the data we are having. But when it comes to the features, when it comes to the x values and all, simply we cannot remove that thing. There should be some sort of okay, dimensionality reduction and all. Variable importance plot is there. Yesterday also we have seen in the presentations. So where with the help of the random forest and decision tree, you can generate that variable importance plot, where it gives how the variables or how the features are contributing to our whatever the features or whatever the data set we are working, and whether that each and every feature or how each feature is contributing to our analysis. So that thing can be observed, guys. And most frequently used kind of thing is the principal component analysis, where what it does is just it is making use of some multi-dimensional aspect. So just we are having various kinds of data and all these particular data items. So maybe all dimensions may not be helpful. We need to remove certain kind of the dimensions. And I have collected some sort of the data for us guys to simplify, because always this scikit-learn you need to prepare, but only the problem is with the usage of the scikit-learn, a little bit mathematical aspects also required. So at this moment of time, you can go by the concept understanding, and in further, so definitely while offering ML machine learning exclusively, I'll try to scope all the mathematical and statistical background. In fact, that is the major course we are going to release in a while. So within that particular course, definitely will provide all the mathematical and statistical background. Probably that is for the mid to senior level members. And and one more thing is uh, by that time, just I'll consolidate all the things like this. It goes and implementation of the algorithms with scikit-learn and as well as the MLlib of the Spark, so that we can also have the flexibility of working with scikit-learn or else this MLlib. Okay, but even one happy point for us is guys, even clients are also not insisting us to go by MLlib based, because scikit-learn all flexibilities we are having, and of course we can directly use pandas or else matplotlib or whichever the things, either with Jupyter notebook by configuring Spark, or else Google Collaboratory, or even with the Databricks also we can make use. So if there is no complexity, then we don't have any objection to implement the same. And moreover, one of the important aspect is friends, resource availability. So we are having a plenty of resources in terms of scikit-learn compared with the MLlib. So MLlib is bit distinct notion where you have to be very particular about that. Like it is a map reduce kind of aspect, how we are converting the data into the key value pair. The same way, just the MLlib also having certain kind of the conventions. Whereas in terms of scikit-learn, we are pretty clear that just we are having loading after loading up the data, pre-processing, and then train test split. Once that is over, just model fitting, and then prediction, metrics, and visualization. There is a clear path. But though outline is same, but in the MLlib, some estimators required and all. Okay, so that I'll show you in after completion of this initial discussion. Right. Now, the dimensional reduction, what exactly this dimensional reduction is? In machine learning, dimensionality refers to the number of features in your data set. What do you mean by dimension, friends? Here, if you consider the dimension is the number of features, maybe 100 features or 150 features, however. So what do you mean by curse of dimensionality? So this is the problem we need to observe, guys, because the difficult of searching through the space gets a lot harder as you have more dimensions. Because assume that you are having many dimensions in your hand, and you need to establish a kind of the relativity and identification of the patterns with respect to those dimensions. And obviously, guys, when the number of features is very large relative to the number of observations in your data set, certain algorithms struggle to train effective models. Okay, so reason behind is pretty simple, guys. Some of the algorithms are not equipped with full learning. Though we are saying machine learning algorithms, many machine 15 to 20 algorithms are there, even more, but majority of the times we'll use 10 to 15 algorithms in both the ways, like in supervised of classification and regression, in the unsupervised of clustering, principal component analysis, association rule mining, all these kind of the aspects. So these algorithms are having some sort of limitation, okay, while working with huge amounts of the data. So this is also called as curse of the dimensionality. Okay, and this is it is especially relevant for distance calculation models like KNN and clustering, because guys, these two algorithms are heavily struggled actually, because if you consider one example long back we have seen, friends, if you remember, KNN and naive Bayes is having those two algorithms are having the advantage of identifying the missing value imputation automatically, and then they can handle the things efficiently, friends. So what I mean to say here is all the algorithms may not be having superpowers. At the same time, they're also not. They behave like, sometimes they're dumb also. Okay, and sometimes those algorithms are really good, especially in the case of the KNN. It is very good in terms of handling missing values, and KNN can be utilized for the regression also, though it belongs to the classification. But KNN, if I am not standardizing the data and it is based on the distance calculations, automatically your results highly influenced by the higher range of the data. Okay, maybe we are having the age, experience, and salary of the employees. Then automatically, friends, what happens is these particular concepts, these high dimensional data, causing some kind of the impact on the algorithm, and algorithm feels that this is most important value we need to consider. Okay, is giving wrong impression actually. So because of the distance measures, obviously these kind of the algorithms suffering with this curse of the dimensionality. Okay, now what is the benefit of removing the dimension? It's probably a silly question, but guys, maybe some indirect advantage also there. And direct advantage, if I'm saying, it reduces the complexity, and it reduces no need to scope all the dimensions. And with the by removing that particular dimension, in a way, we can remove the burden of the model also. Okay, so straight away we can run on the cluster so that we can achieve the results. So every data engineer or data analyst or machine learning developer can say this. But apart from that, friends, one more, some other aspects are also there. That's what I thought of compiling these things and discuss these points in the session. So the benefits initially involves, it takes care of multi-collinearity. Okay, it takes care of multi-collinearity that improves the model performance. Friends, here multi-collinearity. So suppose dependent or independent data items are there. if they are having some kind of the relationships, and especially if you are considering the collinearity is a kind of correlation. So how they are relative, how they are relative, and if I am considering the independent items x1, x2, x3 like that, and if there are strongly dependent, I assume that here one simple example I can give. If you consider a team, and within that particular team, all the 10 members are having the same capabilities. Rather, 5 members are having similar capabilities, and other 5 members are having the other parallel capabilities or parallel skilling, cross skill kind of thing. Which one is generally better, guys? The second case is generally better, na? Because first case, all the homogeneous kind of the thing. If any challenge comes out of this particular box, then everybody are on the same page. Like, just they have to go and verify, and like they're on and at the same thinking. And one proverb is there: if you are thinking same, and if you are in the room, if all are thinking same, and no one is thinking. So similarly, if you are having same kind of the skill set, but why I'm talking this point is, guys, in terms of data engineering, machine learning, data science, you cannot satisfy, or you cannot yourself stop learning. Because um, if you are considering your previous aspects or next aspects, then you will be in the middle act always. So that at least you need to have the essence of where I am getting the data, and where I am pushing my data to the downstream for the analysis or for the deployment, etc. So you need to always have the understanding of your previous data and as well as the next data. So where the same case is not true for Java developer or Python developer, but if you consider the landscape of the data engineering and machine learning, you are a continuous learner, friend, and you should keep on implementing the things, and you should be dynamic in nature. And most importantly, your language skill is different, and your coding skill, all these algorithm skill, okay, but your common sense reasoning is most important, friends. Because at the moment you are thinking about a particular problem, and you have to think through in the point of customer view, and at the same time the whoever originate that particular problem, okay, client view also you have to observe. So your role is dual actually. So it's not always demanding you to write some heavy code or analysis that particular code that is there. But apart from that, the data storytelling is also one of the important consideration. Okay. Now the removal of this thing, and remove the redundant information or features. Suppose, guys, if two features or three features are conveying the same information, if I'm asking 10 members about a particular project, all 10 members will give the same SRS kind of thing. Rather, I can ask only one member. So I'm as the voice of all 10 people is same. I need not go and ask every time the appropriate thing for everybody. From everybody, I need not get the information because that information is common. So here also, by removing this this dimensionality, the redundant features can be removed. And I need to talk about this, guys. I'm having this literature with me. In a while, I'll talk. Overfitting can be handled. At a glance, what do you mean by overfit is, guys? Suppose I'm having the model training and as well as the model testing. If your model is really doing well in the training, maybe 95, 96% of the um, predictions or accuracy we got, but in the testing phase, it miserably fails. Maybe 70 or 75% only we got. This is the situation is known as the overfit. Okay, I'll tell you the reasons why overfit comes and all the things. But with the reduction of the dimensions, friends, we can handle the overfitting condition also. Okay, the terminologies are most important, guys. K-fold cross validation, grid set CV, overfitting, underfit, model, algorithm, metrics, okay, dimensions, features, dependent, independent variable, why predict, why test, train test split, okay, all these kind of the things, okay, just to have a look. and it fastens the time required for performing same computations. Okay, if I want to perform same computing repeatedly, it is fastening. If you consider the KNN or clustering, by removing the higher dimensions, automatically the KNN and clustering performs very well. Okay, in fact, especially in the distance-based kind of the computings or the similarity kind of the estimation. Now you see guys here, it helps in data compressing and reducing the storage space. This is understood. This is everybody can say that, like if I am removing the number of records or number of features, then automatically, friends, we'll end up our searching process with quite performance based. Okay, automatically the unused or unnecessary columns we have removed. And here your understanding is like this, friends. Maybe unused column in the sense it is not always which is not contributing to the corresponding model. At the same time, multiple attributes or giving the same information, we can say that also not required, guys. Because as a data scientist, you need to think through like your how I am getting the different information or uh, or distinct information from multiple features. If all the features are giving the same information, probably you need to do something to avoid that repetition, repeating the data. And because here the algorithm always try to learn from the data, and if no learning is happening due to the common kind of the repetition, that is not the exact requirement, guys. Our requirement is we need to get the variance and various kinds of the inputs from the data, and accordingly the algorithm can take care about the functionalities. Okay, so don't feel that only, however, these three features are contributing heavily, but the contribution we have to see whether that contribution is different with one feature compared with another feature. That is also important point, friends. So, so as to avoid that redundancy and all these conveying the same information. Okay, right. And reducing the dimensions of data into second, third may allow us to plot, visualize it precisely. Because suppose I'm having 100 features, and practically if I'm drawing the appropriate visual representation also, we may not properly observe the relations and correlations. But whereas if you could able to get those particular dimensions down to this 2, 3 or whatever the dimensions, then obviously you can clearly highlight, guys. Okay. Now, if you remember, one we have seen some pair plot actually. So pair plot is something which is giving us some sort of all the relationships with each feature. So suppose feature 1 to feature 10, if I'm having F1 to F2, F1 to F3, like that, we have seen some grid kind of the example. So there, friends, all the features, whatever I'm having, if I want to get the correlations or kind of the association, then I can go with the pair plot. And generally, before launching any kind of the project, the pair plot, heat map, okay, all those visualizations along with the describe and info. Because before touch basing on your algorithm or generating the model, first you should have the complete understanding of the data, friends, because your strength is your data, and even algorithm or model is not dependent on your programming capabilities, but they're dependent on the data and how better you pre-process the data, how better you maintain your data up to the level of learning. Then those in that way we are going to get some betterments, guys, in the understanding and all these kind of aspects. Okay, so this is what how you can specify the dimensional reduction. But in terms of scikit-learn, we observed some complex aspects, and for our understanding, I have simplified this thing, guys. And types of the dimensional reduction. We are having various types of dimensional reduction. Out of that, feature selection and feature extraction. Feature selection in the sense, in this way we try to find out the subset of the original set of the variables. We don't want to go by all the variables which are available. As the name implies, just we are selecting, or to get a smaller subset which can be used to model the problem. Okay, it's always challenge, guys. It's not that much easy. Though we are saying feature selection or feature extraction kind of thing. The feature selection is trying to find out the subset of the data from the appropriate features. Okay, and feature extraction, this reduces the data in high dimensional space to lower dimensional space, that is with a lesser number of the dimensions. Extraction, selection is nothing but finding out of the subset of the data, and we are going with that subset of the data for the analysis. Whereas this particular extraction is something where you are reducing your dimensions. So n dimensional space I am having, and if I want to reduce it to some 2 or 3 dimensional kind of thing, then I can go with the feature extraction. And one of the best approach in the literature provided to machine learning developers is principal component analysis, which is also known as PCA, principal component analysis, which is a best way of reducing the dimensions. Okay, so it is having some mathematical representation. So if you observe this diagram, guys, this is a Gini expression data actually. So Gini expressions data is the most complex data where we are trying to find out the relevancy of the Gini indexing and all, because that medical data and this is that is containing so heavy patterns, huge patterns. Now generally those out of those particular patterns we need to have some specific combination of the patterns. So these dimensions can be reduced with the help of the principal component analysis. Just again the point is, guys, internally the PCA gives the ranking, the priority kind of thing, and it estimates the strength of the features. Just it considers all the given features, and it is going to rank those particular thing according to the mathematical notion. And based on that, you can go by top 2 or top 3 kind of the dimensions. So in a way, you can observe the kind of the relationships, and moreover, the least ranked data also you can see whether they are really contributing or whether we can draw some kind of the insights from data. Friend, there is a distinction actually. Removal of the data is different and selection of the data is different, friends. Because extraction, as I said, feature extraction is something like which we are striving for reducing the number of dimensions. Whereas feature selection is a subset of the data where we are periodically selecting some kind of the features, and we are seeing the impact. Now, in this particular case, guys, actually the selection, forward selection, backward elimination. Forward selection in the sense, starting from the first attribute, you are keep on growing that particular set into the superset. Okay, just we are keep on adding that features. Whereas backward elimination in the sense, just we are removing one by one dimension, and we see if any sudden drop is there in the accuracy or precision values, then we have to observe that that feature is really giving the support, or it is really helping to take the decision by the model. So these are all logical, guys, highly logical. And though we are having some standard literature and all, but this is not a rule kind of thing. As I said, these are all the best practices where you can adopt, provided based on your requirement, these particular practices can be considered. So that is how you can see the representation of principal component analysis. Let me give you the insight what exactly we have seen. So PCA is a method of extracting important features in the form of the components from a large set of variables in the data set. Just it is a method of extracting the appropriate data. It extracts low dimensional set of features from high dimensional data set with a motive as such information as possible. Because our intention is not to remove the data, friends, to understand the data, to learn from the data. But at the same time, the data should not cause the trouble for our understanding. And sometimes it becomes a barrier, because if I am making use, one more important point, friends, don't learn unnecessary things. because you may feel that okay, I have to learn everything. And it is obviously one proverb I have read somewhere, guys, like, while climbing the ladder, if you are having all the small kind of the money or whatever the baggage, and while climbing up you are taking more bags, you cannot climb fast, guys, to the appropriate destination. Similarly, if your aim is to become a good data engineer or good data scientist, then just you pick up whenever there is a requirement. That is what I'm very cautious in the exhibition of the trainings also. um, just whenever there is a requirement, just I will give that information to you, and will cut that particular aspect and move ahead. So here the context of this understanding is completely different, guys. That's what I'm saying. So unlike if you refer the Python or Java kind of the development, as much as you learn, it is definitely somewhere helps you. But if you are getting more concepts which are not relevant or required now, then you will be automatically you end up with some other practices. So that is what how you can see this particular learning is especially based on the projects. Okay, that's what I'm giving all the um, experiences and trainings to you. So how to prepare a presentation, how to project that, and then yourself how to pick up the project, and how to present that particular project related to that. All these kind of the conventions are most important aspects. So here the understanding is um, uh, so here the understanding is just you can make use of convention, like how we are generating the things and all. So this is what how you can refer the principal component analysis. So it extract low dimensional set of features from high dimensional data set with a motive as much information as possible. With fewer variables, visualization also becomes much more meaningful. Okay, much more meaningful, and it is always in a symmetric correlation or covariance matrix, and should be numeric and have standardized data. Friends, observe that no matter whether I'm using the dimensional reduction, whether I'm using some sort of other practices, all these kind of the data converted into the numericals or numbers, because that number only gives the impact, the priority values. So because we're having the ranking, we're having the numbers. So automatically that number internally having some sort of a mechanism of which is best out of the best things. Okay, likewise, you can observe the principal component analysis. Already we have seen some 1,000 rows and 50 columns. There are too many combinations. With the help of the PCA, we'll end in less dimensions and capture as much information as possible. Okay, it doesn't mean that, guys, we are losing something, but only the thing is after removing the unnecessary aspects, so definitely we can see the necessary information. We also always feel that some of the aspects are important for us, but later realize after, because that is the power of human being, guys. Initially you may enter into the wrong practices, but later you definitely realize, because we are having that thinking process, understanding capabilities, and from experience we can realize, okay, this is not going to help me. Definitely I have to rethink and re-examine and come back in a better way. Okay, so this is how you can refer the dimensional reduction practice. And as I said earlier, guys, there is one more subtopic I want to cover here. um, that is what you call the uh, k-fold cross validation. The problem here is, guys, suppose we are working with some project, assume that, and that project is to understand the placement record of NITs and IITs. Okay, so NITs and IITs, that is the problem given by government to our company, assume that. Because they want to empower, because if I am talking about the nation, and these IITs, NITs are nation builders, actually engineers. Those institutions are producing the engineers. So obviously those engineers are the future of our India. So in that case, Like that is the project we got, and we are having the details of NITs and as well as the IITs, but we only study the IIT data, and we came up with some kind of the analogy where all your algorithms or all your implementations are related to the IIT based data, and you have done everything and trained your data and you got some accuracy. Okay, all these kind of things, you are happy with that. But at the moment your teammate given the NIT data rather than IIT, obviously the data is a brand new for our model. Okay, just observe here, guys. We thought of studying about the IIT data, and we have given that particular data to our model, and it has done well. It has seen all the possibilities, and it has given some sort of okay, whatever the statistics we are having, and we are going to generate 2023-24 statistics also based on the earlier one. This year also CSC, IT, Triple E, ECE, all these members, 97, 98 percentage of the people are going to place. That is our analysis. But at the moment I give the NIT data, it gives only 80% or 75 percentage of the accuracy, because you have not given the all the flavors of the data to your algorithm. You have not set the kind of the algorithm. So in that case, friends, just the balancing of the data is most important. The balancing of the data, that is what you call your k-fold cross validation. Um, this k-fold cross validation, what it does is just it is splitting the data into the buckets, and it is going to pick up the appropriate information in all the possibilities. Okay, so suppose if you consider we are having 100 rows and 10 columns, and in the traditional machine learning strategy, we can use 75 25 or 80-20 or 70-30 training data and test data split. We can use that. But what we're doing here is, guys, just after getting these 100 records, again, we are making use of some sort of B1, B2, B3, B4, B5. And these are all nothing but the buckets, which are nothing but the storages. And we know that 100 rows are there. And what we are doing, we are segregating this particular 100 records into 20 each. Okay, so all 100 records are segregated to these 5 buckets. Now, the point of what exactly this k-fold cross validation is, this particular k-fold cross validation, out of this particular 5 buckets, 4 buckets will be taken as the training, and fifth one, B5, is taken as the testing, and you observe the accuracy. Similarly, in the iteration 2, this time B4 is dedicated to the testing and remaining dedicated for the training. And in the third iteration, third bucket for the testing. So in a way, guys, what we are doing is we are giving all the combinations of these particular buckets to our model. Then what is the benefit of doing so, guys? The benefit of doing so is uh, you will be your data will be exposed to the corresponding model, no matter whatever the portion of the data you are giving for the testing, as it is already observed that particular data, then automatically the accuracy remains high. Okay, without dropping the appropriate convention. Okay, so this is how you can handle the imbalanced data set, because data set imbalance always creates some kind of the problem at the testing, guys. Training is very good, and in the training you're nice, your model is performing really well. But at the outset, after making use of this particular training data, and suddenly if I'm giving all together a new data, then it leads to the uh, miserable reduction of the corresponding accuracy. So as to avoid that particular thing, the best methodology is the k-fold cross validation. Okay, this is one you can see. And one more thing, guys, if you remember grid search CV. So if you consider the grid search CV, this is something like this point, guys. Actually, your k-fold cross validation. Let me share this thing, guys. One note. Any message I got? Oh. already academy people entered into our genre, right? Okay, so I'm having priority task. Okay, go ahead, no problem. Yeah, right. Thank you. Thank you, Nisha. And okay, so just let me share the one note because we have to see some kind of content, guys. Like, just a minute. So best practices. Okay. So just what we're dealing is initially we're talking about the k-fold cross validation. And this particular k-fold cross validation is nothing but whatever the data I'm having, this data will be split into k buckets or storages. Okay, and then uh, the combination of these buckets spread to train and test. Because by doing so, just we are giving the information of the corresponding data item to all the the model can get all the information about the data, all the possibilities, all the dimensional data, combinations of those things. And thereafter, friends, next I have set like grid set CV. So this particular grid set is nothing but suppose assume that, guys, I'm having the some sort of support vector machine, and there I am having the C value. I am having some kernel value. Like that, I'm having some other parameters. Okay, these things, but I don't know. Again, each parameter is having some set of the values. Assume that kernel also related to this particular kernel, we are having sigmoid and we are having linear. Okay, likewise, we are having some sort of the radial basis function. Okay, likewise, we're having kernels and something like that. P3 also we are having some kind of the values, value 1, value 2, 1, 2, 3. So now you see the combinations, guys. Here we are having 3, 3, 2, and 3. Even if I'm checking all this particular combination, again, I need to dedicate some time and space for this best combination. So what this grid set CV does is internally it perform the activities. It picks up that the best possible ways, like C, if you are keeping 0.1, it is good. And kernel, if you are keeping as a linear, it is good. And your P3 value must be V2 so as to get the best result. And P4 is V3. Now you see, guys, here, rather than focusing on rather than focusing manually on all these kind of the parameters. Suppose if you consider any experience, guys, like maybe you are having offers data engineering and data science in our company, and in data engineering, just will be working with some kind of the client. Okay, where we have to go to office. Where in terms of the data science, we are working for some other client. This is client one, and this is client two, and where you can work from home. So these priorities, it may be changing from person to person, guys. Suppose some people are interested to go to office so as to have the complete understanding. And initial days, this is preferable, guys, because with the personal attention, and if you are going personally to office, definitely you will be getting all the information. Okay. So virtually also it is possible, but initial days of your understanding or your project, definitely because resource usage and as well as your doubts will be resolved physically. So uh, based on that group of okay, based on your mindset, you can select that. Whereas in terms of data science, generally senior members would be there, and whether they are present in office or whether they are working from home, they can manage the things. Okay, so they can opt for this particular option, this form. So likewise, in this particular case also, your model or based on your data, just your grid set CV supports the combination of the best parameters. Always the selection of the parameters is a tedious task, guys, because manually if you are doing also, every time you have to verify what is the outcome, and accordingly you should behave. Okay, selection of those kind of the parameters after verifying all the things. But whereas if you consider the adopting the grid set CB, automatically the best possible combinations you can get. Okay. Now, moving back to our scikit-learn, because I have to see some other considerations related to the, yeah. Okay. So we have seen this dimensional reduction, and apart from that, especially from the DE perspective, we are having the pre-processing techniques, guys. Okay. And as far as if you consider the dimensional reduction, we are having PCA, feature selection, and feature extraction. Okay, if you consider these things, okay, definitely all these things are not required. And factor analysis, okay, this particular factor analysis can be done with your decision trees or random forest also, because it gives the variable importance plot and all those kind of the conventions. Now pre-processing, this is most important, guys, for every DE member and all these things. Uh, if you consider the pre-processing, what do you mean by pre-processing is just the data might be in all the shapes, and it is whatever the data we are having, the data may be having higher dimensions, maybe the missing values, and we may need to convert that into the some common scale. Okay, encoding may be applicable. So our different things are there. Friend. Pre-processing is a, I can say, compared with the algorithms, pre-processing of the data is very crucial. Okay, because algorithm and understanding of the hyperparameters and implementation after one or two examples implementation, you can get the clarity. Okay, after completion of one cycle, even after completion of the 3 or 4 cycles of the projects, but your pre-processing is demanding much more from you guys. Uh, if you are considering this thing, if you see the left hand side of this pre-processing, standardization or mean removal and variance scaling. What do you mean by variance scaling is, suppose friends here, we are having some age data, experience data, and as well as the salary data. Variance scaling means there is a huge variance between salary and experience, and age and experience more or less a similar kind of thing, maybe two-digit kind of thing I can say, but your salary value is far higher than these values. Then we have to scale them uh, to reduce or remove of the variance, because the variance is conveying some different meaning to the model, which should not happen, guys. Okay, so like whatever the measures we're having, just what we're doing is the standardization. So just we're making use of this particular thing, and we want to handle all those particular data into the scaled format from 0 to 1. Okay, all these kind of the data items, rather than giving the higher ends, just I can make use of this data into a common factor. Okay, and along with those kind of the convention, we're having the normalizations actually. Okay, so normalization is a principle where, if you refer this point, guys, normalization is a process of scaling individual samples to have unit norm. Okay, common unit, and this particular normalization, this process can be helpful if you plan to use a quadratic form such as dot product or any other kind of the kernel to quantify the similarity of any pair of samples, quantify the similarities. And this particular normalization gives that the appropriate sparse based matrix. Friends, here sparse means a matrix which is containing more zeros. Okay, compared with the numbers, if it is containing more zeros, then that can be known as the sparse matrix. Generally, in terms of normalization, just we are making use of these kind of data items into a common factor. So just this particular normalization helps to handle the sparse matrix kind of thing. In a way, you can avoid that zeros and you can maintain the space, because for the heavy data items, while using these dimensions and all, you may need to allocate the space for all the dimensions and all. And suppose if you apply the normalization, all these kind of the things for zeros, you can avoid the memory allocation. So in a way, you can save the space kind of the things also. That is how you can see this normalization aspect. Now, friends, one more point actually, encoding. Can someone help me, friends? We have seen these categorical features. Can you give some examples related to the categorical features? Categorical, maybe the blood groups, male and female, and then we are having this movie ratings. Okay, and two kinds of the categorical data items are there. One is uh, no, mm, nominal and another is the ordinal. So ordinal is having some order, maybe ranking of the students, or else movie ratings. All these kind of the aspects comes under the category of the ordinal, because internally the data is providing some sort of the order, and we have to preserve that order up to the level of the algorithm also. Now, if you are talking about the encoding techniques, as you know, guys, label encoding is there, where some sort of zeros and ones, yes or no. Okay, those kind of binary formats can be taken as a label encoding. We are having one hot encoding and dummy encoding also. Those kind of the encodings, just conversion of the data into zeros and ones format, which is quite handy while performing the activity on top of the data. Okay, if you are not performing any encoding kind of aspects, automatically, guys, it requires more. Rather than processing the textual data or string kind of the data, if you could convert the data into the numbers, then it is always quite handy to implement the algorithms and understanding. Okay, so just already we have seen this one hot and label encoding and dummy and target encoding also we have seen in that session, guys. Okay, these are all the examples, and likewise we're having imputing the missing values. And here there we have seen some 5 different aspects, friends. So how to remove the attribute and how to remove the records, and how we are going to add some default value, or else how we are going to add mean, mode, or median. Last and a recent update is even some algorithms also can be used to perform the missing value imputation. Okay, so it all depends on your requirement and all these kind of things, guys. That is what how you can see the usage of this encoding techniques, and predominantly, guys, standardization, normalization, encoding, imputing the missing values. These are all important aspects you have to practice in general while working with the data pre-processing techniques. Okay, so dimensional reduction and all these things are same. Now, just if you are referencing other thing, friends, here the model selection definitely comes under the category of grid sets. If you see cross k-fold cross validation, grid set CV, these are all the other best practices, guys. If I'm clicking on this, they are nothing to do with the algorithms actually. So this cross validation is nothing but evaluating estimator performance, and then tuning the hyperparameters, metrics and scoring, quantifying the quality of the predictions, validation curves. All these are various model selection and evaluation, because though we are having, you can ask this question like we are having metrics and measures also, but why I need to go by this model selection. Because see friends, the metrics and as well as the measures are not particular to your algorithm, but particular to your classification and regression. And there is no specific there is no except in case of logistic regression, there is no specific measures or metrics for classification and regression. Okay, because the point is, friends, if I'm talking about the confusion matrix, AUC, ROC, accuracy, precision, recall, F1 score, all these things belongs to the entire classification techniques. Whereas if I'm talking about yesterday also our friend has given some demonstration related to Seshi has given the demonstration on the regression measures. Okay, R square, adjusted R square, RMSE, RAE, all these things. They are not specific to a particular algorithm, but your model selection for this particular data set for this kind of the environment compared with the naive Bayes support vector machine is good, because here we are having the multi-dimensional or n-dimensional kind of thing. Whereas compared with the decision tree, naive Bayes is good here because we are having the more weak learners, so that we need to give preference for the weak learners also. That is the specification, guys. And for those kind of the things, this model selection and evaluation, okay, you need not be pro in all these things, guys, because definitely all these things are not going to help in all the ways. Only in a particular situation, almost all whatever the commonalities we're having as a best practice, we can able to implement with respect to the algorithms. But at certain point in time, maybe your existing capabilities or literature or training is not that much helpful in a particular situation. In that case, just to jump to this blog or this particular site, and so that you can get definitely the relevancy, because they are all researchers and they're having all their points in mind, so that obviously you can have your whatever the requirement you want, just you can fulfill that. Apart from this thing, guys, because pre-processing DE activity, dimensional reduction DE activity, model selection is a combination actually. Okay, after implementation of the models and all those things, just we have to observe whether this model is we can do any betterment, or is there any better suggestion we get like that. And as I said, just you can join in these kind of the communities, guys, because definitely these are all authenticated kind of the developments. Okay, and these are all nothing but what's going on and what exactly the up-to-date information. So most recent activities and all those kind of the things can be observed here and then. And our normal thing, so but to be frank, guys, compared with understanding of the classification, regression and clustering, these three are challenging, guys, because the DE guys should be very cautious. uh, because the ML and again, data scientist is a superman, where his purview is not limited to only DE or ML kind of the landscapes. His capabilities are different, guys. But when I am comparing between DE and ML folks, definitely the challenges lies with the DE hands only, because how best you are fine tuning your data, how best you are putting your efforts to so as to empower the corresponding understanding, in the same reflection would be there in terms of the algorithm. The algorithm is a static one, guys. Algorithm is a static one. But whereas your model is dynamic, because that model is the combination of your data pre-processing, your algorithm, and as well as your hyperparameter tuning, and all these kind of grid set CV, k-fold cross validation, all these kind of the conventions. So we should be very clear. The data engineers activities crucial, guys, because all these kind of the techniques, okay, you should apply, and you should supply the corresponding fine-tuned data to the ML guy. Okay, so this is what how you can refer. These three are major pillars of data engineering. Now, this is a quite common classification, regression, and as well as the clustering mechanisms. And these things, as already we have talked about SVM, naive Bayes, KNN, and random forest, decision trees, all these kind of the classification. Regression, if I'm saying, like, linear and multilinear kind of regression techniques we have seen. Clustering mechanism yesterday we have seen, and apart from that we are having k-means and hierarchical and principal component analysis. Okay, all these things, association rule mining belongs to the unsupervised category, but clustering is a specific thing. Like, I cannot say association rule mining related to clustering, but that belongs to the unsupervised learning actually. So these are all the ways how you can go with the understanding of scikit-learn. And one more thing before landing with bias variance trade-off, just I collected some information for us guys. Let me copy this particular thing and I'm pasting in the this thing. Yeah, you can download the book guys. Actually, this is official Databricks data engineering guide, and it's not only for the Ds guys as well, because as a machine learning engineer, you should also have the understanding of the pre-processing techniques and all those kind of the conventions. Okay, now this particular guide is quite handy when it comes to the certification, when it comes to the in a simple preview, the entire aspects were covered in this handbook guys. I loved it actually because it is such a great book with 94 pages only. Generally, if you observe data engineering or machine learning kind of books in ORL or some other, it's 300 or 400 pages. Of course, it requires also, but it is always friends fun. Initially, maybe if I want to get some kind of the essence of my learning, definitely I need to have some precise or concise kind of the book, and it belongs to that category only. And see how we started giving the introduction, Spark tool set, different types of the data. Already we have seen all these three friends. You can realize easily what exactly Spark cluster management tool. And here he discussed about basic architecture and application of the Spark. And he has he's talking about driver and as well as the executors in simple way. And our cluster manager is managing both the Spark session and at the same time executors also. Okay, so and just we observed that within the executors, we're having the slots and all those kind of the conventions. Now moving ahead, and these APIs, just various APIs are there. Maybe by default you can use the Scala, or else you can use the Java programming language, Python, SQL, and R programming. And moving ahead, just we are having how JVM is supporting the Python or R based kind of aspects. So just your Spark session running on top of this particular JVM, and it is getting the executor support. And the same Spark session is communicating with the PySpark or else the R kind of the process. Okay, and now, so just we are having the Spark session, which is of course the entry point where you can make use of this thing in the formats like, I can able to pick up this Spark session with the help of this Notion and directly this is the Scala based guys, val and var if you see, but whereas in the Python you need not declare any kind of variables. Directly you can make use of the spark dot range. Already we have seen directly we are converting this spark dot range directly generate the RDD. Just we are converting to that data frame. Now discussion about the data frames, which is nothing but a high level API, commonly used structured API, and moreover it is giving us a tabular kind of the structure so as to maintain the data. And there we are having some sort of partition information, where partition is nothing but your data is going to store into a number of partitions, and on top of that you can apply the transformations. So transformations are operations provided by Spark, and they are lazy in nature. And then we are moving ahead, just there are narrow and as well as the wide. Just we have seen this kind of the convention. And with the help of the this diagram, you can observe that in case of the narrow, it is a one-to-one communication. And in case of the wide transformation, just that is also one-to-one, but each and every partition may be involving in some sort of other outputs. Okay, multiple outputs can be observed. And then moving ahead, just we're having actions. Actions are nothing but the real workhorses. It is triggering the activity. Okay, but transformations are lazy in nature. But whereas if you consider the actions, definitely we have to execute that. So in the order of whenever I want to run some action, obviously the dependent transformation should be executed. And in a way, the action picks up the data from those transformations and it is going to generate the data. And most importantly, guys, the Spark user interface, where we have seen the DAG in the earlier session, someone has presented. And if you are considering this user interface, it is giving the knowledge about jobs and stages, and as well as how many tasks are running, how much time has taken, all these kind of the conventions you can see. Now, end-to-end example, this is of course, and thereafter just you can see how we are loading the data and performing the sorting operation and all those kind of the conventions. Now one more point guys here, your data frame RDD, and of course data set is not there in our PySpark, but that is there in the Scala. As we are focusing on the PySpark, it is enough to go by RDD and data frame usage. Okay, and then data frame and SQL, how I need to use the data frame and how I am able to create the appropriate uh, table. So just we have done that, create or replace temp view. Just we are making use of this kind of the data. And from now onward, this flight data 2015 can be used to apply some kind of the SQL based queries. Okay, directly I can make use of the convention. See here in Python way, spark.sql. Just you can run through. Okay, so just in that way, you can perform the activity, and there are certain physical plans and as well as the logical plans. In the SQL format, how we are running the data. See here the physical plan. Just it is performing some hash aggregate and all those kind of the shuffling and all those partitions it is doing. And at the same time, in this particular case also, as I said earlier, guys, in terms of SQL and your data frame way of execution, programmatically, maybe there is a differentiation. Like Spark.SQL, what we're doing is just with the help of a typical select and group by option we have done. But whereas in your data frame directly, what I can do is with the data frame name, just I'm applying the group by option and count. Likewise, we are taking the convention. Okay, and here the SQL way dot explain give the physical plan, and data frame way dot explain gives the physical plan of the data frame way of doing the things. And fortunately, guys, just we are having the same kind of the performance in terms of SQL and as well as PySpark. The people who are cult SQL programmers or SQL lovers, they can simply use the data frame and they can turn the appropriate coding into the SQL based. Uh, but we cannot deny the usage of the DF also, guys, because this is also quite handy when you are entering into the genre of the PySpark. Nothing wrong in the usage of the Spark SQL, but give a try to this data frame orientation also. Okay, moving ahead. Just there is a explanation and some more examples. Okay, all the way how I am performing the activities related to data frame and Spark SQL. Okay, so this is the further. So how this particular data is running through, and there is a logical representation. Okay, and with column, actually there are two important options, guys. One is with column and second is the with column renamed. Your with column renamed is something like so just you can make use of some renaming of the column existing on that data frame. But whereas with column is having higher capabilities compared with column renamed. With column, you can add the column or you can perform the manipulation of the corresponding column information. All these kind of the conventions are possible with respect to the with the column. And there along with that, we are having Spark toolkit actually. This particular toolkit, like Hadoop ecosystem, how we are having this thing, we are having this toolkit friends like low level API. This is a distributed variable broadcasting and accumulator. If you remember, long back we have seen related to the RTDs. And remember, guys, in the certification also, if they are asking structured API, then either that SQL, data frame or dataset, all these belongs to the structured API. And ecosystem plus packages. This ecosystem may be involving Hadoop ecosystem like Kafka usage, Scoop or Hive, whichever. And then streaming kind of the data. Streaming guys, actually that particular streaming aspect, so as to perform either Spark is having its complete process of the streaming with their packages, and or else you can integrate that particular streaming with the Kafka also. Okay, likewise you can perform the activity. And in the ML discussion, definitely in the ML orientation, just where I'm going to embed this streaming concepts also, probably with the Kafka integration. And usually also we can see both the case studies and with the ML graph and as well as the deep learning, which is something like convolutional neural network, recurrent neural networks, most of the image processing and most of the times if you want to perform some audio or video kind of the analysis, then you can go and make use of this kind of the convention. And one by one, just based on the requirement. Okay, so just you can go through with these things. And why I'm giving this particular session is, guys, straight away we are getting some kind of the questions in the certification from this document only. Okay, that is one of the, you can take this as a handbook for the preparation. Okay, that's what I'm insisting to go. And from this point, just the machine learning kind of the things and advanced analytics. Just the data frame orientation and loading of the data, understanding of the pre-processing techniques, all same schema and all. But here he's explaining about the algorithmic aspects. K means clustering. Okay, he started with that. And now guys here the coding, as I said earlier, just to have a look on the coding, whatever the code we have taken, whatever the code we have applied in our RDD, the same thing leveraged to the data frame. And then similarly with COL and LIT and substring and select expressions, and moreover with column, in every time just we are using the same kind of the logic or same kind of the syntax. There is no abnormal change in the syntax and usage of the corresponding data. So here also in the machine learning perspective, just what we need to do is just if you consider, I'm giving the example, guys, there is a extensive coverage on that actually, ML pipelines and all, or else just I'm parking this thing and I'm going back to the ML because this particular thing is a continuation actually. But let us see, however, if I'm introducing this particular pipeline aspect, understanding of the pipeline and how I am performing the data pre-processing and how I am selecting the corresponding algorithm, you can easily understand here. Okay, so after completion of this understanding, then we'll come back to this simple case study, right? Okay. Now see guys here, what do you mean by a pipeline? Okay, generally pipeline, especially in terms of the Spark orientation is you need not write multiple lines of the code where you are expecting to continue your output to the next step. Within the single statement, you can perform the activity of pipeline. So it is providing a uniform set of high level APIs built on top of data frames. Observe here, guys. Generally, pipeline aspects are applicable on top of the data frames that help user create and tune practical machine learning pipelines. Okay, now coming to this particular thing, and this pipeline involves various algorithms and which is inspired by scikit-learn. And here in Spark documentation itself, they are referring the scikit-learn library, friends. Just now we have seen. Okay, and which are all the constructs we are using? Data frame, of course, we pretty know that, and transformer. And you need to observe this thing, guys. Transformation is different, friends. Transformer, which is used, is an algorithm. A transformer is an algorithm which can transform one data frame into another data frame. Maybe ML model is a transformer which transform a data frame with features into a data frame with predictions. See friends, how simple the definition is. A transformer is simply an algorithm where you can apply you can apply this particular transformer on top of the data frame. So your data frame along with the features, okay, just it is converted into the data frame with the predictions. So it becomes a model kind of thing. Estimator is nothing but the predictor, guys. So that is what I said. There are small distinctions between the scikit-learn terminology and as well as our Spark terminology. Whereas we say this transformer as a model fit in terms of scikit-learn usage, whereas this prediction is nothing but the estimator. Now you see, guys, here an estimator is an algorithm again which can be fit on a data frame to produce a transformer. Example, a learning algorithm is an estimator which trains on data frame and produces a model. Final model selection. Okay, all these things belongs to the estimator. Now pipeline, chain of multiple transformers and as well as the estimator together to specify ML workflow. If someone asks you what do you mean by ML workflow, you can say data frame, some transformer on the data frame, estimator on the corresponding data frame. So all together, if I'm combining, then it comes to the ML workflow. And most importantly, guys, there are certain parameters. All transformers and as well as the estimators now share a common API for specifying parameters. So once you design the transform and as well as the estimator with the help of this particular workflow, now you can change that particular parameter setting. Maybe if I want to use a decision tree, I can just specify the name of the algorithm. Or if I want to use the support vector machine, I can make use of that kind of the convention. Now further, if I want to see the implementation, then this is a logical diagram, guys. Let me give you this particular diagram where this is just you can observe how we are getting the convention of understanding the flow. Okay, so just to have a look on this pipeline and all the things. Okay, now, so just if you see this, guys, text and conversion of the boards, feature vectors, maybe I'm using the logistic regression model. Logistic regression, though it is naming as regression, but it is belong to the classification. Friends, DE guys, don't get confused. Logistic already we have seen, guys, like the numbers converted into the probabilities, the values converted into the probabilities. Where our interest is just if you consider the log sort ratio, logit function, the main important aspect, guys, there. Suppose if I want to check whether the mail is spam or ham, um, yes or no kind of the conventions can be implemented with the logistic regression. It is a purely classification kind of aspect. So at times your logistic regression becomes quite handy, especially in terms of using the probabilities and at the same time best fit line, all those kind of the conventions. Okay, now coding wise, if I want to mention, like guys, just I'm giving a coding here. Yeah. So already some of the examples we have seen related to our machine learning algorithm. There is a slight change, guys, actually. So like rather than using from scikit-learn library, your linear model and all, here directly I'm using the from PySpark.ml. Okay, linear algorithm, import vectors. Okay, because most importantly, guys, I need to use the vector assemblers here so as to establish a kind of the pipeline or so as to maintain the flow of the data. And here I'm using PySpark.ml dot classification. Okay, classification. Just we are importing the logistic regression. Now prepare training data from a list of label feature tuples. And this is your wish, guys. Maybe you can go by the corresponding entries, whatever. Just is taking some example here. Okay, so just is creating some list of label comma features, whatever the label I'm having and corresponding features. Okay, so this 0.01, 1.1 like that is taking some data and he identified that thing as this is the label and these are all the features. The difference between label and feature is, guys, feature is your input data, label is your output data. That's all. Now, how to create a logistic. This is also same in our example, like, after importing your logistic regression algorithm, what we are doing is just we create the reference of that. Here also we are creating LR logistic regression, but only the point is we are sending some arguments in some parameters, like in terms of maximum iteration and as well as the regularization parameter. Okay, and now we are printing the parameters like explain parameters kind of thing. Now this is a model fitting, just whatever the training data I'm having. So just here I'm having the training data. We are fitting this model. Okay, now this model one contains the appropriate reference of the model. Now what you can do, guys, just we are going to understand the parameter map, and then we are because this is a logistic regression kind of things, we are repeating 20 times, 30 times like that, and we are updating the corresponding parameters. This is all under the purview of hyperparameter tuning technique and all. Now the probabilistic value little different, guys. Here, these things are not required in our scikit-learn library, but how they follow the convention of PySpark orientation, because everything you need to establish, guys. There is no internal mechanism as of now. Now that is model one actually. Let me go with the model two with the different parameters. Okay, so just I'm having comparison between one and two. Now the testing data, okay, rather than applying on the training data, now I want to test this particular data. Okay, so model 2 dot transform of test. So your model fitting is a reference dot fit training data and as well as the parameters, whereas your prediction involves whatever the model already you have fit. On top of that, just you can transform with the test data, and then you can declare or you can publish this particular results, all those features and how they are getting the predictions and all. Because even we are not using the kind of confusion matrix and all. There is a little distinction, guys. Definitely we have to agree, because only the point here is whenever you are making use of this ML based library of the Spark, you should be using that vector assembler, pipeline aspect, ML flow, and manual submission of the parameters, all these things, because these 4 or 5 points are different when compared with your MLlib scikit-learn library. Okay, in Spark MLlib library exclusively talks in terms of data frame, transformers, estimators, parameters, all these things. But whereas in terms of our scikit-learn, just we are making use of that model fit, model prediction. That's all. These two. Okay. A pipeline aspect, the same kind of the convention with a certain combination of the things, and model selection, hyperparameter tuning. And here we are having the ML tuning guide. So just this is talking about your model selection and cross validation, all these kind of the convention. So just let me paste this particular thing also, guys, where you can see this is for the sake of ML, guys. And the earlier thing, whatever we are having pipeline and all, this is for the D and ML both. Okay, so just have a look on this thing. This is also another thing. Okay, so but definitely have a look on this, and if not, again, moving back to this particular example. Now what we are doing, guys, here, if you are talking about string indexer and all, where I want to pick up the day of week or day of week index. Because in the earlier example, while giving the date time functions by Arif or who, someone has given that date time functions really good. So Pawan has given. So he discussed about how I can make use of these conventions like day and date functions and all. Even directly I can pick up year, a day and month kind of thing. And as a explanation, Pawan said that in Spark 3 we are having some further aspects also. You may not give all the capitals, in small letters also it accepts. So those kind of aspects, and one hot encoder. This is some sort of encoding techniques. See here, just I am applying this import one hot encoder from pyspark.ml.feature engineering, import one hot encoder. And once you familiar with these kind of things, guys, but only the thing is in the pipelining only, just you can observe the estimator, a transformer, all those kind of aspects. Okay. Now moving ahead, just we are taking the vector assembler, where this particular vector assembler is a most commonly kind of things where you need to combine all your features, guys. That is the main important thing. The tagging of all the features and segregation of the feature with respect to labels is most important and distinguishing feature. Okay, so just there is a differentiation of that thing. But whereas in case of scikit-learn, we're having the train test split actually. So with the help of the train test split, nicely you can segregate the things and directly with that slicing operation of the Python, you can perform the activity, guys. Now establishing the pipeline where we are submitting all these indexer, encoder, and vector assembler, because individually we have performed the string indexing and then we have taken that vector assembling, and here we observed that encoding with the help of the one hot, and now you can combine all those things into a kind of pipeline. Okay, it's quite handy once you start working with these kind of the mechanisms, guys. Okay, and this is the extension of that and how we are implementing the k-means clustering. Just we are making use of the clustering, import k-means and reference as usual number of k values, because that elbow method already we have seen in the earlier example. Elbow method is something like which is guiding us to set the optimized k value. So with the help of that particular optimized k value, one can easily specify that k value, and after that if you are giving higher number also, it retains the same results. Okay, so this is how you can low level API, just we are having parallelize and row, all these things. And apart from that, Spark core is not in our purview. Working with different data types, we have seen user defined, null values, date and type, strings, number, and boolean. Complex type in the sense, guys, maybe the structure type, and we have observed that numerical kind of the data, int type, float type, all these kind of the aspects. And then how to handle this particular various APIs, maybe the JSON working, and as well as Parquet, and we worked with textual data. Okay, this is a kind of summary, guys, if you observe. Okay, all these kind of the data items and all. Conversion of the Spark types. Even we worked with these kind of thing, how to convert the data types and all. And thereafter, LIT, COL, okay, in like all these kind of things we have observed, even comparisons. These are all examples. And Spark type conversion, alias are converting from string to the appropriate integer. And even we worked some kind of the projects on that, some case study where if I want to generate a particular salary per month rather than yearly salary, that is one thing, and conversion of the salary string into the integer kind of the data. So float kind of the data, those things were observed, and you can create the new column creation. Okay, like whatever the imputations and whatever the calculations you want, you can perform that thing. And these things we have observed. I'm just rechecking what exactly we have covered and all, and string working. So, and then regular expressions are not there actually, but still regular expressions are nothing but to handle the textual data, friends. Maybe if I want to pick up some, especially this is helpful for the NLP kind of thing, so that we have not scoped that thing. Okay, it's not a big thing. Just if any member is interested to work with the text data, or maybe currently you are dealing with the textual kind of thing, then I suggest you to have this regular expression study. And I will give some other data also for you guys. I'm having some literature on that. I'll share with you. And dates and timestamps already we have seen in the earlier presentation. Some example this is, and let me conclude this thing. Working with null data, yes, of course, missing value kind of thing we have seen. and complex types, maybe select expressions. Okay, all these aspect ordering and JSON. Already we have seen JSON, Parquet, and all these kind of thing. User defined functions. Whereas there we have seen some 2 to 3 distinct notions. Just with the help of the Python definition, we have seen. And there is one more thing with decorators also at the rate symbol. Directly I can assign the appropriate function into some sort of the variable. Here a quite simple example. So you can see the beauty is he has given both Scala and Python orientation. Though the Spark is built on top of Scala, but they are not denying the usage of Python, because majority of the people are working in Python only, guys. Now see how your UDF is working and how it is distributing, because um, UDF is something like which is a customization friend, because many built-in functions are there in Spark, but still why we are behind that UDF is not all the built-in functions may satisfy our requirement, because the client needs and as well as the developer needs are growing like anything. So one of the best option is still we can make use of that particular convention with our coding. With coding, you can do anything, guys. Okay, whatever the functionality I need, just we want to perform that particular thing with the help of the coding. Now, similarly, the user-defined function, though we are having rich set of the predefined functions and built-in functions, but still there are quite a lot of avenues to make use of this user-defined functions. Now you see, no matter whether I'm using the Python UDF or Scala UDF through driver, just we are contacting with the Spark session and we are having all the executor process. Okay, so initially the function serialized and sent to the workers. Serialization in the sense maintenance of the corresponding state of the data. Similarly, for the sake of the function also, you can maintain the data, because maybe that UDF is containing some parameters, maybe that is expecting some kind of the outcome also. So now the executor process, just whatever the resources required, the executors worker nodes along with the slots are mapped with the task representation. Now in the second stage, the Spark starts Python process and sends data. Um, just if you are considering the Python based kind of the UDF, maybe our definition with respect to Python or decorator should execute, because generally the function containing some particular task, and after performing the task individually, all these particular executors are returning the answer. Maybe all the executors supporting the running of this particular UDF, accordingly the return value will be there. And one thing you observe, guys, here while writing the function, it is mandatory to return the value, though it is supporting not returning value, or you can you need not or you may not require, but still as per the standard procedure of the function creation, function should contain say function should accept the parameters, and as well as it is performing some task. After performing the task, it should return some value also, guys. So that is what how you can observe in the representation of this Python based user defined functions, or in Scala also the same procedure more or less. And whenever the Python process is running, just it is picking up all the data. Finally, it is going to return the answers. Okay, this is a simple example how you can observe the usage of user defined. And there we observed how to register and how to perform. Even if you consider, guys, in Scala, we have to explicitly register, but we have not done the same in Python. Just what we have done is just we have imported that UDF, and directly we tagged that UDF with our Python based definition, and then we directly call that function with the help of this thing. Okay, so this is the way the distinction, guys. In Scala, definitely we have to register. Maybe in terms of Pig Latin or Hive also, this registration is there. But in our Python, there is no registration kind of aspect. Directly, I can reuse the things. Okay. So these are all, and data lake, that is not the scope of this course. So that if any member interested to go and have a look on this, just go through and perform this. And one more thing, guys, our Databricks is really giving some sort of the badges actually. So if you refer lake house fundamentals, if you consider, uh, this is you can where you can start. So if you want to officially get some certification from the Databricks kind of thing, then you can make use of this convention, guys. It is also free training, and which is giving some introduction to data lake um, and Databricks Lakehouse platform, and how this particular Databricks Lakehouse platform architecture and security are helping the other things. I mean, from this particular storage only, we are getting the support and supported workloads on the Databricks Lakehouse platform. So this is a short tutorial, guys, because where just you can earn a badge of this Lakehouse fundamentals. You feel that okay, you can get some kind of the certification from Databricks. This is probably the initial point where you can enjoy the certification from the Databricks. Okay, no matter whether you are DE or ML or whichever. And further, guys, after that you can raise your bar by considering other kind of things. Okay, other certifications, just if I need to give the clarity on that, let me give that particular clarity, and then we'll have a break. Databricks various certifications, because the DE side we are having, and mm, DE side we are having, ML side we are having. So starting from the analyst, okay, just we're having certain kind of the certifications. For the analyst, definitely you have to clear that Lakehouse badge. And majority of the thing, guys, for the analytical kind of thing, insights, creating queries, visualizations, dashboards, and Databricks SQL is not into the API usage predominantly. Okay, so that you can have a look on this Lakehouse and all these kind of the things. Okay, for the analyst, you can have this particular associate. And if you refer the kind of the concepts you need to study, like you need to have the SQL fundamentals, data integrations, and then Lakehouse platform, and Delta Lake, storage and management of the tables and all, security, and structured query language, SQL also, basic SQL, complex data, Lakehouse fundamentals, all these things, and then dashboards like visualizations, all these kind of things. So analyst aspects are is a kind of mixture of all the things, guys, because there is no specific API. With the fundamentals, you can perform the activity. Now here, Databricks SQL 22% of questions you will be getting. Data management around 9 questions out of 45. SQL, okay, majority of the questions from SQL, and data visualization and dashboards, some 8 questions, and similarly analytics applications, okay, some 5 questions you will be getting. Okay, so this is how you can refer, because this is not requiring any PySpark or Scala. It is based on the SQL kind of thing, friends. It is quite easy to crack this particular exam. Okay, and of course instructor led and self-paced. So just to see that. And frequently asked questions document also you can download. Okay, so this is for the sake of the data analyst. Whereas if you are considering the data engineer, first you can aim with the data engineer associate. Okay, who is having the design, develop, test and maintenance badge, streaming data pipelines on top of the Databricks Lakehouse platform and its capabilities. So initially, if you are referencing the already we have covered this thing, guys, many of the aspects, and here we are having data lake house architecture, data science and engineering workspace, clusters, notebooks, and data storage, and Delta Lake. And more or less, guys, the UDF functionality, PySpark, Spark SQL. Okay, so all these things and understanding of these entity permissions. Okay, but may not, if you are considering the basis of the data engineer kind of the certification, we are having various platforms, guys, here. Data engineer associate and some other aspect also there. Data engineer associate Spark, PySpark developer. Okay, so and in that particular case, just you need to have the RDDs and data frame APIs, all those kind of the conventions. Just you check the certification and accordingly, professional certification little bit advanced, guys. So here you can clearly see that all the advanced kind of the aspects, notebooks, Apache Spark, just we have seen. Okay, we have covered these aspects predominantly. PySpark, data frame API, basic architecture, and Delta Lake, Databricks CLI. And because this is somewhat command line interface, generally we are not using, guys, just we are using our community editions only. And REST API, it is like, with the configuration and triggering some kind of the activities, production pipelines. If you are a DevOps or if you want to deploy those kind of things, then and ETL processing, pipeline aspects, optimizing workloads, duplication, and change data capture. Okay, if you want to have the professional certifications, these things and data management with the lake house and especially, guys, data modeling concepts. The members who are seniors might be knowing about the data modeling kind of thing, where keys, constraints, lookup table, slowly changing dimension. Okay, which is of course very favorite topic, guys, in data warehousing ETL process. That SCD1, SCD2, SCD3, slowly changing dimensions. Okay, so those kind of things. And then remaining aspects, guys, how we are distributing, how we are getting the distribution of the questions is likewise. Okay, and but if you consider the ML data scientist kind of thing, if I'm referencing the associate level certification, you can start here, guys. All the ML guys, you can start here, where just if I'm making use of this associate level. Here, basically, clusters, repos, this is common in case of basic certification and associate certification. And here you need to study about the libraries, classification, regression, and forecasting, feature engineering, and tracking the models, model registry, all those aspects. Exploratory data analysis, guys, like, data pre-processing, feature engineering, like missing value imputation, one hot encoding, and tuning, hyperparameter tuning techniques and all. Evaluation, cross validation, evaluation metrics in terms of your classification and as well as the regression. And implementing machine learning solutions like distributed ML, data splitting, training, evaluation. Just now we have seen estimator and transformations, pipelines, hyper optimizations, Pandas API on Spark, UDFs, and functionalities. Remaining things are linear regression, decision trees, ensemble. Ensemble is nothing but this thing, guys, actually random forest. All these things belongs to the ensemble methods. And machine learning 29% will be getting workflows like transformers, estimators, all those things. Spark ML lib will get some 33%. Scaling of ML models 9%. So friends, here associate exam you can take, guys, like if you are having some whatever the preparation from our training, so directly you can make use of that convention. Whereas if you want to become a professional certification is a little heavy workload would be there, guys. Let me show you that. Okay, in this case, this version involves directly we'll go to the question pattern. See, that is the problem, guys. There, there is no separate segregation for that because always advanced and professional certifications are like that, especially in the ML kind of thing. And here, let us see then in that case what to do. Data management and tracking of the ML flow, advanced experiment tracking, manage the machine learning model life cycle, because main thing is after implementing your ML algorithm, what exactly you are fine tuning. All those kind of the aspects are coming under this. Implementing the strategies, and streaming is also there, guys. Batch processing, all these UDFs, all these feature engineering and all works, and streaming. So just we are having that individual streaming of the Spark. Generally, they ask Spark streaming only, guys. They don't go by Kafka or any other tool. Okay, Spark streaming is enough, and real-time deployment option. Okay, how we are deploying the models and all. Monitoring solution for drift detection, and there is any issue related to usage of the higher resources. Okay, so this is bit I mean tricky, where just we need to have that understanding, and FAQs also you can see, guys, where you can have a look on that. Okay, so these things, and example questions also you can able to observe, guys. Okay, and however, I'll be sharing the previous questions and all, both DE and ML aspect. Just you can have a look on that and perform well. And one more, there are other things, guys, apart from the data analyst, data engineer, and all these things. Um, Actually, I am looking for this one more option. Yes. This thing, guys, actually. Apache Spark Developer Associate, Platform Administrator, Hadoop Migration Architect. If you consider this thing, these are specialty badges actually. This you can crack with the knowledge of your Python, and as well as RDD and data frame. Now you see, guys, here clearly many things are there here: selecting, renaming, and manipulating columns. Okay, this I am recommending you for both ML and as well as the DE, guys. Okay, because this is the way how you can start your journey. Because once you clear a certain exam, more or less the same kind of the pattern you will be getting. Okay, once you clear this particular thing, first thing is lake house, that badge you earn, guys, from the Databricks, and then you start with this thing, and accordingly you move ahead. Okay, so like so just selection, renaming, and manipulating columns. Already we have seen filtering, dropping, sorting, and aggregating with the help of the group by summation, average, all these things. Join data frames, reading of the data, writing, and partitioning. You are reading, writing in terms of JSON, and we have seen some Parquet, all those kind of the conventions, and working with the UDFs and Spark SQL functions. And majority of the topics, architecture concepts already we have seen. Out of 60, 10 questions we are getting. Architecture applications. Okay, total 17 questions are there, guys. Maybe architecture and as well as the architecture application, and remaining 43 questions all are from your API only. Architecture applications maybe, guys, here like RDD or your accumulator, broadcast, all these kind of the things. Okay, so with the quite understanding of this RDD and as well as the data frame orientation, you can perform the activities. Okay, and apart from that, for the senior members, there are some other badges are also there, guys, specialty badges, where at least you need to, there is a convention actually, like at least you should have some three different three already existing certificates, then only you will be allowed to do that. Maybe that is the platform specialist. Okay, all those, yeah, this one actually, platform administrator, Hadoop migration architect. Okay, all these kind of the convention. So just you select uh, a data analyst kind of thing. Majority of the works are related to the lake house kind of things. Just to see that you can clear that simple lake house certification as a badge kind of thing. Whereas if you consider the data engineer, we are having associate and this exam and the professional exam. Associate certification is there, professional is there, and whereas and is giving clear this thing also, friends. Lake house fundamentals, and then go to the associate level, and then go to the professional level. Whereas ML data scientist, basically associate certification you can register straight away, guys. But whereas if you And one more thing, machine learning practitioner. This thing actually, if you follow this particular basics, like how Ds are following the lake house based kind of thing, you can follow the lake house fundamentals and then go to the associate certification. Okay. So apart from that, the other thing is the professional certification, whereas a little advanced, where you need to manage all the kind of the parameter tuning, transformers, estimators, all these things we have seen. Okay, so it all depends according to your requirement just to go through. However, initially, just to clear that lake house, which is not going to charge any more, guys. And just we are there is the option, guys. You need to contact your manager so that we are planning to reimburse that thing also, so that you will be getting. Okay. Uh, this is how you can observe the consideration of clearance of the certification and all. Okay, this is the way you can approach. There's a clear distinction, DE, ML, and of course there are some intersections also, friends. Uh, just usage of the RDD and understanding of the Spark architecture. And if you consider the data frame API in everywhere, no matter whether you're a data analyst or data engineer or data scientist, in everywhere we are having that notion of the usage. Like these particular three aspects are common in all the aspects. First to clear that and then move to the specific certification and how to start. So first to start with this delta lake friends. Okay, so what this particular delta lake is and which are all the processing of loading and saving our data. Okay, and this is also a bit advanced, guys, because in the delta lake fundamentals only we are having some four videos, actually very simple videos, those things, and just have a look on that. Okay, so with the help of that particular thing, you can complete the aspects. Okay, you can move ahead with the DE or ML kind of things. And once the break is completed, guys, just will be talking about regularization techniques, where there we are having the overfitting and as well as the underfit kind of thing, and how we are going to solve that particular aspect. And once that is over, just will see how we are making use of the best practices. Already we have seen, just let me consolidate all those kind of the things. Okay, now let me uh, give the key takeaways before the break, because once we are coming from the break, this is a there is a finalization of overfitting, underfitting, and all those kind of things. Okay, we have seen many things, guys, but it's a kind of connecting the dots. So key takeaways. The very first aspect is we started with um, dimensionality reduction. We studied about principal component analysis, feature selection, feature extraction. And then the second aspect we covered k-fold cross validation. Okay, so as to handle train and test data with balancing nature in a pure balanced way. And then we have seen some grid search, and we have studied about that Databricks handbook. There we started by architecture, Spark architecture details, and then along with that Spark session. And thereafter, guys, we have seen some low level API, RDD, and then structured API, something like data frame and Spark SQL. Once this is over, we move to some sort of the DE concepts. Many are there, guys. I'm giving you a few things. COL, LIT with the column renamed, select, so that in a way you can also pick up those things. Select expression, filter, group by, count kind of thing. Uh, anything comes to your mind, friends? LIT also seen. Okay, like sub-str. These are all few aspects we have seen in the observation. Now, latest ML aspects we have seen, and there basically we studied about the concept of the pipelines, transformers, estimators, and let me go back, friends, 1 minute. Apart from that, we have seen some other notions. ML pipelines, transformers. 1 minute. Estimators. That's all. Transformers, estimators, and pipeline, and some kind of the parameters we have seen. Okay, so those things are already covered. And then latest the certifications. Within that, there are initially my recommendation is complete the Lakehouse fundamentals. Uh, which is free, of course. 4 videos are there, and after that they will ask you some MCQ kind of thing just to attempt that. And for the data analyst, some kind of the certifications we're having. Data engineer also, associate, professional. For ML or a data scientist also, we are having again associate and professional. Associate you can directly register, guys. And there are some special badges where in this we're having Spark associate developer certification. Almost all our training covered all these things. You can take this certification, and their Hadoop migration specialist is there. Our platform admin specialist is there. So based on your requirement, just you can choose either of these things, guys. And what next? So in the after coming from the break, just will introduce you overfit and underfit and how to resolve. And moreover, one more topic is there actually. I want to give you regression assumptions. This is also they're asking, guys, in machine learning kind of aspects. So let me give you these two and we'll complete. And if any members are there in the call to give the presentations, just